Good afternoon, everyone who, like me, is in the Eastern time zone or some other time zone where it's already afternoon. And good morning to everyone else. And thank you very much for attending our Wireless LAN Protocol Analysis Tips webinar this month. We here at CWNP for the last several months now have been doing a monthly webinar to give you some valuable technical information about our certifications and so forth in order to help ensure that you understand where CWNP is, where they're going, and the different technical knowledge bases that you need to have to prepare not only for our certifications, but to use wireless networking hardware and gear effectively. My name is Tom Carpenter. As you can probably tell by the sound of my voice, I am not Heather Hobbs. I am Tom Carpenter, simply logged on with her account in order to give the webinar presentation today. And so I'll be the presenter as we go through talking about wireless LAN protocol analysis tips. And just so you know, if this is your first time being on one of these monthly webinars with us, we try to keep them to around 30 minutes. So generally somewhere between 1:30 and 1:40, we're attempting to wrap up because our goal is to get you some good information as quickly as possible and let you get on about your day so that you can function and do other things that you need to do. Also, you should know that we do two of the webinars. We do this one at 1 p.m. Eastern Standard Time, and then we do another at 9 p.m. Eastern Standard Time. So there are a couple of options for you to attend every webinar that we do, one in the morning, one in the evening Eastern Standard Time, or those times, of course, applicable to your local time zone to help you have the opportunity to be on the webinar with us. Now, the first thing I want to do is make sure that you understand what CWNP is all about. CWNP is a certification organization, a vendor-neutral certification organization to be specific, in the wireless industry. And specifically, when we say wireless, we mean 802.11 based wireless LANs. So this is what we're dealing with. Now, there are interconnections to other wireless technologies, Bluetooth, Zigbee, RFID, and even cellular. So there are interconnections, and there are some basic levels of knowledge that we might require in some of our certifications that you have about those other wireless technologies. But our primary focus is Wi-Fi. And all of our exams can be passed if you know Wi-Fi really well in relation to the topic set. So it's about 802.11. Now, our first certification that we actually have is not even in the list here, but it is CWTS, and that's an entry-level certification. If you attend a class, it's either a 2 or 3 day class, depending on how long they run the class each day. And then it's a single exam to get that CWTS certification. CWNA is our network administrator certification. If you attend a class, it's a 5-day class to attend, and it's a more complicated certification than CWTS for sure, but it really is a solid foundation for everything else that we cover in our professional level certifications. So the 3 professional level certifications, CWSP, CWDP, and CWAP, are focused on security, design, and analysis or troubleshooting. So what we're looking at here today would have some applicability to CWNA, but also to CWDP and CWAP, and even some to CWSP. Probably mostly applicable to CWNA and CWAP, because we're focused on protocol analysis, and CWAP is about analysis, troubleshooting issues that might exist on wireless networks. In fact, I should point out that we have just launched into the update process for all of our CWAP materials. The new objectives are done and will be released within the next couple of months. A new study guide will be coming out in the first quarter of next year. We'll have e-learning products, entirely new course, really focused on troubleshooting. So CWAP is about troubleshooting and making sure you understand how to analyze problems in wireless networks. Now, of course, the elite level certification is the Certified Wireless Network Expert, or CWNE. There's no exam for that, but you have to have already passed 4 exams. CWNA, SP, DP, and AP must already be under your belt. Then you can apply to become a CWNE. If you apply to become a CWNE, it means your application is going to go before the CWNE Board of Advisors. These are 6 stern-looking individuals. No, I'm kidding. There's 6 individuals who themselves are CWNEs, and they're very fair. They evaluate the application, and when it is rejected for some reason, they always tell you why, and we give you guidance in how to enhance your career, your skill set, or your application so that it can be approved the next time. And We have CWNE applications coming in all the time. There are several before the board right now. So these are the certifications CWNP offers. Of course, to learn more, go to cwnp.com and look at our certifications there. Now, the agenda for today's presentation for the next 25 or so minutes is, first of all, why perform protocol analysis on wireless networks? What's the point of it? What are the benefits? Why should we do it? Second, what tools are needed? So if I'm going to do protocol analysis, how do I perform this? And then thirdly will be several protocol analysis tips as we cover some information about using protocol analyzers, troubleshooting specific kinds of scenarios, and we're even going to wrap up today with a brief discussion of the fact that wireless LAN administrators must do wired protocol analysis in many cases as well. And we'll talk about why that is. So this is our basic agenda. And with that said, we'll go ahead and get started. Now, as we go throughout the presentation today, you'll notice there's a chat window that's available to you. If you don't have the chat window open, you can click the chat button at the top of the screen in order to make it visible. If you type any questions you have into that chat window and send them to all participants, that'll be the best way. So rather than sending a Q&A just directly to me, instead send your question or comments in the chat window to all participants. Feel free to discuss. If you have a tip about the thing that I'm currently talking about you want to share with everyone, simply chat in your tip in the chat window that you see there on the right-hand side. And that way you'll be able to share your knowledge as well. And if you have questions, ask those, and I'll do my best to simply answer those questions as we go along. Okay, so the question then, why protocol analysis? Why would we even want to do this? Well, the thing is that protocol analysis is about bits and bytes. Protocol analysis is about frames, right? And so since protocol analysis is about frames, we have to ask ourselves, why would we need to look at frames? What would the point be? Why do we need to look at them in the first place? Well, there are four common reasons why we need to do protocol analysis. The first one, the obvious one, is troubleshooting. So when there's a problem with the wireless network, we can use protocol analysis to try to locate the problem. Now, we don't always use protocol analysis to locate the problem. For example, there are problems on wireless networks where you intuit, you know, based on your experience, what the issue is. For example, you may know the symptoms of a DHCP server that has the pool depleted. And so you know that you don't need to do protocol analysis. You know the DHCP server pool is depleted and you've got to deal with it. So there are certain things that you can just recognize them and you don't need a protocol analyzer to troubleshoot it. But then there are things where you do want to use a protocol analyzer. For example, you may go into the configuration on a client device and configure it to use quality of service for a certain type of communication. And you notice that it doesn't seem to be helping even though you've done that on 150 such devices. Then you take out your protocol analyzer and look at it, and you actually see that even though you change the setting in the configuration, there are no quality of service markings in the frames. What's that tell you? It tells you something's broken in the device, right? So you can contact the vendor, you can say to them, look, I made the changes according to your instruction documents, and still I'm not getting any quality of service. And they might say, well, yes, you are. And you can say, well, I'll send you the protocol capture to show you that I'm not. And so that's an example of troubleshooting. Another benefit of protocol analysis is feature discovery. This is understanding what wireless capabilities a device has, because wireless capabilities are specified in the different frames, right? And so if you want to know which capabilities that maybe are new in 802.11ac or were new in 802.11n or what have you, then you can actually capture the protocol packets or the frames with 802.11, and then you can look at these frames to find out what the feature capabilities of that client or AP are. So feature discovery is one benefit. Another is performance monitoring. Now, performance monitoring is a little challenging with the traditional protocol analyzer. And by traditional, I mean like Wireshark, okay? So Wireshark is about capturing the frames and then simply displaying the decodes to you. And yes, there are some performance metrics in there. So there's some network statistics, things like that. And you can get add-ons that give you extra performance metrics. But Wireshark, at least out of the box, is not going to be as powerful for performance monitoring as some of the other protocol analyzers that are specifically designed for wireless LANs. But they're going to help you with that. And then the fourth category is security monitoring. And again, Wireshark's not going to do it automatically. You'd have to either write your own tools or get add-on third-party tools to get it for you. But the other protocol analyzers that we'll talk about here momentarily do indeed give you security flags, alerts, for example. You can, in some of them, say, I need to be compliant with PCI DSS, and it will automatically alert you when it sees networks that are not. So these are some examples of why you might want to do protocol analysis. Now, the next question is what tools are needed. So if you want to do protocol analysis, what tools are you going to have to actually do protocol analysis? Well, first, the kind of obvious one, you need a protocol analyzer, right? A protocol analyzer is a piece of software that runs on your laptop or certain tablets in some cases. Surface Pro is great for this, and other tablets like that can run standard desktop Windows software. So laptop, tablet, something that can run the software, right? Now, there are two categories of protocol analyzers, commercial and free, or open source or public domain, or whatever term you want to use for it. So commercial, we have really three major software competitors that we see most commonly used. And that is Savius, AirMagnet, and Tamosoft. And Savius used to be Wild Packets, but it's still OmniPeak, and then Wi-Fi Analyzer Pro and ComView for Wi-Fi. Now, I'm not going to give you the ins and outs of every one of these protocol analyzers today. We just don't have the time to get into each one of them. But I will tell you that they have different feature sets. And so OmniPeak is not Wi-Fi Analyzer Pro. Wi-Fi Analyzer Pro is not ComView for Wi-Fi, and ComView for Wi-Fi is not OmniPeak. They are very different tools. And frankly, there are some great features in each one of them that are not in the other two that I like. And it's kind of sad that for most of us, we have to pick one of them, because the reality is if I could capture my frames and then open them in the one that's most useful for what I'm trying to do, that would be ideal if the budget was there to get all three. So if the budget's there to get all three, or if you could attend conferences and possibly get licenses for 6 months or 12 months or something like that, depending on what the vendors might be offering at the time, it's not a bad idea. And it's certainly not a bad idea if you're just getting ready to buy a wireless LAN protocol analyzer to try all three of these and put them through the paces and see which one's going to have the best feature set for you. Watch webinars that the vendors might put on about those wireless protocol analyzers as well, because sometimes you might miss some features that are in there that you'll be exposed to in those webinars. So these are your commercial protocol analyzers, and the commercial protocol analyzers have the ability to both capture the frames if you have the right adapter, and to decode them and also give you very nice reports, graph-based reports, things like this that will help you do performance analysis, security analysis, and other things. Now, the fourth thing that I'm listing here as commercial is integrated. What this means is the protocol analysis is built into the access point. So many access points do protocol analysis. The vast majority of them are simply going to, in the AP itself, give you the ability to capture the packets and not really do any analysis of those packets. But when you have centralized management, there may be some packet analysis capabilities built in for various types of reports. So integrated protocol analysis means the AP is doing the frame capture, the packet capture, so that you can then analyze that. And sometimes you'll capture it on the AP and then open it up in the protocol analyzer. Sometimes the protocol analyzer can directly capture it using the AP as the capture device. Okay. Then we have free. Now, the free protocol analyzer is Wireshark. And generally, my recommendation is if you're going to use Wireshark to do 802.11 protocol analysis, then do it in Linux. And so you can get Kali Linux. A new version of Kali Linux 2.0 was released sometime back around July or August. I forget the exact time. But the newest version of Kali Linux does now have you have to install them separately, compile and install them. But there are some drivers for a few 802.11 AC adapters now. So you can actually do 802.11 AC capture in Wireshark, in Kali Linux, in the newest version. But you got to get the right adapter. So for sake of time, I would encourage you, if you're interested in that, do a quick search on the internet for 802.11 AC adapter, Kali Linux, or something like that, and you'll find that there are 2 or 3 adapters now that are out there that you can actually utilize. So Wireshark, the main focus is just decodes, letting you see the frames. And there are some statistical reporting elements built into Wireshark and other things like that that are useful for you too. In fact, what some people may choose to do is use Wireshark to actually capture if they have the right capture tools with Wireshark, and then they'll pull that capture file into one of the other protocol analyzers. Now, you also need hardware. So it's not just about the software, you need the hardware. And the main thing with laptop-based capture or tablet-based capture that supports adapters is having the right adapters. Now, if you're using something like, say, a MacBook Pro with 802.11ac 3x3 built in, then you've got the built-in capability to capture 802.11ac frames on your MacBook Pro. But for laptops, generally we need the right adapter that works with the capture software. And by the way, that's an example of what I meant when I said sometimes you'll capture it and then load it into your protocol analyzer. So you can use a MacBook Pro to capture the frames, and then you can load those frames into ComView for Wi-Fi, Wi-Fi Analyzer Pro, or OmniPeak. Now, how do you know what adapter to get? Well, the answer is you need to go to the vendor websites and you need to look at the adapters they support. And you need to pick the adapter that is supported and meets your needs. So for example, if you need 2x2 11AC, and that's all you need, then you need to find the right adapter that does that. If you only need 11N 3x3, you need the right adapter that does that. So you've got to find the right adapter, and sometimes your hands are tied. In other words, you might go to one of the vendor's sites and find, well, if you want to do 3x3 11AC with our software, you either need to do it through an access point or you need to buy our device that you have to pay extra for in order to be able to do the capture. So sometimes your hands are tied in that way. And then with other vendors, they may support some 802.11ac adapters, but not many. And of course, you've got the MacBook Pro that can do the capture of the 802.11ac 3x3. So you need the adapter or the AP, and I'm going to mention it one more time for lab scenarios. I've mentioned this in 3 or 4 webinars over the last year. For lab scenarios, one of the best APs you can get your hands on is the Cisco WAP 371. And that is all one word, WAP 371 by Cisco. Just typed it into the chat for you. And that particular access point is an 802.11ac 3x3 AP that has built into it the ability to capture the frames. So you can put it on the channel you want to put it on, you can capture the frames, and then you can download that PCAP file and load it into your protocol analyzer, or you can have your protocol analyzer talk directly to the AP to do the capture. So for today, for right now, that's really great because you can shop around and find those APs often for under $200. So it's a really good AP to use in a lab type environment. I have implemented those APs before in facilities and they do work. I'm not extremely fond of them for any kind of a large scale deployment, but they work okay for small scale deployments. But my focus here is recommending them for this great use in a lab environment when you're trying to study protocol analysis, or even in a production environment when you want a protocol analyzer, because you can actually take the AP around with you and power it with power over Ethernet and do your capture with the AP, and then take that capture file and analyze it wherever you need to analyze it. So these are the tools that are needed. All right, now let's talk a little bit about some of the tips and things that you need to know and keep in mind when it comes to doing protocol analysis. First of all, it is important to know or remember that your NIC has to be operating in the right way. Your NIC is your network interface card, right? Or your network adapter. So NICs have 2 primary operating modes: promiscuous mode and monitor mode. And the difference between these is that one of them is going to capture everything and the other is not. And it really does depend on the interface, what you're in, what promiscuous or monitor means. Because in some interfaces, promiscuous and monitor mean exactly the same thing. And in other interfaces, they mean something different. So you'll really have to focus on the interface there. But just know that your network adapter can be in a mode where it's only capturing information that's targeted to that adapter, and it can be in a mode where it captures all information. You want it to where it's capturing all information. You also need to be aware of driver compatibility issues. So your application not only will require a specific adapter, but it's going to require in many cases specific drivers. So you may have an adapter that you went down to the local electronics store that the vendor website says is compatible. You get it home, plug it in, go to use it, and it doesn't actually work. But then you go to the vendor website for the protocol analyzer and you download the right drivers, and all of a sudden it works. So that's important to keep in mind. And I'll tell you this too. I purchased one adapter a couple of years ago. I forget which one it was, but I purchased an adapter that worked with one of the protocol analyzers and used it just as an adapter first, and noticed that for some reason the 5 gigahertz band in it was not working at all. It was a dual band 11N adapter, and the 5 gigahertz band wasn't working at all on Windows. I couldn't get it to work. The drivers didn't work. I updated the drivers, got the newest ones, didn't work. And then I installed the driver from the wireless LAN protocol analysis software, and not only did it allow it to do protocol analysis, but just leaving that driver in there, it actually worked in both bands. So the driver was a driver that let it function as an adapter and as a capture device. And interestingly enough, it repaired a problem with the vendor's drivers that did not allow it to actually work at all in 5 gigahertz, even though it was marketed as that. And that was on a particular version of Windows where the drivers did not support 5 gigahertz yet. So there are some interesting things you'll run into there, and you really just have to run through the process of getting the adapter, getting the drivers, and making sure they work appropriately. And also note, if you have an internal network adapter, you want to make sure that it's not connected to any network, and preferably that it's disabled while you're doing protocol analysis with an external adapter. Now, another thing to keep in mind when you're getting an adapter to do your capture is it needs to support what you're trying to do. Now, one might say that goes without saying. Of course it does. But the point here is that you can't capture what the chipset doesn't understand. So you need an adapter that can capture 11N if you want 11N, 11AC if you want 11AC. Not only that, does it need to be 3x3? Does it need to only be 2x2 or 1x1? So what do you actually need to capture? Well, the adapter has to support that to capture it. So it's very important to understand you've got to get the right adapter and right device capabilities. And sometimes you might think, well, it's all about 5 gigahertz today, but remember, it's not all about 5 gigahertz. You've still got old barcode scanners and badges and mobile Wi-Fi devices that might even still be 11B or 11G, certainly. So keep in mind, if they're in your environment and you want to be able to capture them, you still need a 2.4 gigahertz radio in order to accomplish that as well. Now, the next question we need to deal with is, where should I place the analyzer? So this is always a question that's asked. And it's a very good question because, as we know, wireless signals go out in all directions. Now, you might say, well, not mine, I'm using directional antennas. Well, if you're indoor and you're using directional antennas, your signal's still going in all directions. It might just have to reflect to get in all directions, but it's going to go in all directions eventually. Okay, so reflection, scattering, diffraction, all of these behaviors cause the signal to propagate throughout an indoor space. And it goes in all directions. So the question is, where do I need to monitor? Well, here's a general tip for you. In general, you need to monitor where the problem exists. So in general, if you're seeing corrupted frames on a client, but not at the AP, you probably want to monitor near that client. If you're seeing corrupted frames at the AP, but not on the client, you probably need to monitor near that AP. Of course, you're using the protocol analyzer to see where the corrupted frames are. So the point being, then, if you've got a client having a problem with a certain AP, you'll probably want to do some capturing at the AP and the client. The benefit is, if the AP already has capture capabilities built into it, and you can switch that on to capture packets at the AP, that can be helpful. But remember, quite often, when you do that, the AP stops being an AP. So you have to know what your AP is going to do in order to take advantage of anything like that. But generally speaking, you capture where the problem is. And you'll find that sometimes that does need to be nearer the client, and sometimes it needs to be nearer the AP. This is why just saying, well, all of my APs can do packet capture, so I don't need a portable protocol analyzer, is a bit of a naive statement. Because where the AP is, there may not be a problem, but where the client is, there may be a problem. For example, I could go to the client, and in my protocol analyzer, I might see that there's some heavy activity from 2 different basic service areas on the same channel. And so that client is experiencing co-channel interference that the AP to which the client is associated does not see. And so the point is that going to the client and doing my protocol capture can reveal that kind of information to me. Now, when you're setting up your capture, you want to think about your different capture options. And I'm not going to spend a lot of time on this, but you do need to make sure that you're using the right adapter, that you are using the right filters, you're choosing the channel modes you want to use, and I'll talk more about that in a minute. You're choosing the filters you want to use. I'll talk more about that too. You're setting up the capture buffer. How much data do you want to capture? Are you capturing to disk or only to memory? Do you want to trigger? So it's going to look at frames, but only really start capturing if it sees a certain kind of frame. How do you want devices to be named? How do you want to lay out the interface? So these are all things that you can customize in pretty much all of the protocol analyzers. So you want to think those through. Now, two specific configuration settings I want to spend a little bit of time talking about are filters and channel modes. So when it comes to filters, there are two ways that we do our filters. We can do capture or display filters. A capture filter simply means that we're going to discard any frame that doesn't match the filter. For example, if all you're capturing for is to understand the different BSAs that are out there, the different service sets that are building BSAs, I should say, then you may want to only capture management frames. So you could do a filter that only captures management frames. And then you're just looking at that and you're discarding all the data frames. So you can get a lot more of these management frames a lot more quickly to analyze that. So the point though is if you capture only the management frames, it's a capture filter, and then you later decide, well, I wish I could see the other frames, it's too bad. You're not going to be able to see those other frames because you didn't capture them. So that's very important to keep in mind. A display filter is going to limit your display so it's not so cluttered when you're looking at the decodes, but the other data is there if you ever want to see it. So it really is a factor of, do you need the data? If not, then you can filter on capture. If you think you might need the data, you want to filter on display. Also remember there's something called frame slicing or packet slicing that you can do. And basically what that does is just give you the frame headers. So you're getting rid of the actual data portion, the payload, if you will, of the data frames. That can be useful if it's an encrypted network with EAP-TLS or something like that, and you wouldn't be able to decrypt it anyway. Or if you've got a policy that says you're not allowed to capture the data because of privacy policies or something in an organization, then you can slice off the data. You're just getting the headers. From a management perspective, from a performance analysis, security analysis, troubleshooting perspective, quite often all we actually need is that header information when it comes to wireless LAN analysis. Now, one of the important questions that's asked is what file format is the packet capture stored in? Well, the answer to that is it depends. It depends on your protocol analyzer. Most of the protocol analyzers can store it in a PCAP format or something of that sort, one of the PCAP formats, but they also may have their own proprietary format. And so obviously if you store it in the PCAP format or export it to that format at least, then you can open it in other protocol analyzers. But if they are going to store it in only a proprietary format, then you'll only be able to open it in those analyzers. So the format you store it in is usually an option that you have when you're selecting how to save it. All right, so channel modes is another important thing I mentioned that we need to talk about. And when we're dealing with channel modes, what we're talking about is the ways in which we're scanning channels. So it's really two ways, channel scanning and static channels. With channel scanning, what we're doing is we're looking at either all the channels or all the channels that we care about. So sometimes you'll only scan 1, 6, and 11, or in 5 gigahertz, maybe you'll only scan Uni 1, Uni 2. But the point is that you are picking the channels to scan, and then you're going to dwell on each of those scanned channels for some period of time. As you can see in the screen capture here, the period is 250 milliseconds. And so basically every second, we're going to be going on 4 different channels and scanning on those 4 channels, which would mean in 2.4 gigahertz, if we're only channel scanning 1, 6, and 11, then we would be looking at all 3 channels more than once a second on average. So what this lets you do is basically quickly scan and see all the networks that are out there, get a sampling of the kind of traffic that is going on those networks and so forth. The problem with it is it's just a sample. You don't get all the traffic, so you can't really look at conversations, communications from start to finish between devices, and there may be some useful traffic that's missed by using this capture method. With static channel, it's going to give you a big, full, complete picture of a single channel. We're not jumping around on channels, we're just scanning one. And it gives you conversation analysis and very reliable health metrics, if we want to call them that. And we'll talk a little bit more about that in a minute. So you have to decide between those modes of operation. Now also, the ultimate thing that you get once you've done your capture is a decode. And a decode simply means we're taking all the bits, the ones and zeros that make up the data being sent across the network, and we're decoding it so it's meaningful to a human. And what we usually have is a frame header and then the actual payload in hex or ASCII data. And so for the administrator, quite often, you're focused on that header information. You're looking at things like signal strength and this kind of thing. And part of that is available because of something we call the Radiotap header. So the Radiotap header is going to give you information that the adapter saw related to the frame. Things like, for example, the data rate it was sent at, the transmit power, the antenna used, these kinds of things will be in the Radiotap header, the channel that it was on, and so on, which can be very useful for analysis by an administrator because you have the opportunity to actually see this information, such as signal level, noise level, though those are not necessarily considered as accurate as you might get with a spectrum analyzer. They're still useful, but most useful is the data rate in the channel. And I don't know if you're this kind of person, but I still remember the first time I did a protocol capture for 11AC and I saw some of the 11AC rates. Hey, I remember the first time I did an 11N protocol capture and I saw the 11N rates, and I was so excited to say, look, I'm actually achieving that data rate. So you can see that in the Radiotap header, and it's useful information. Now, a couple of tips here as we get toward the end of our presentation. First of all, performance. I mentioned health metrics earlier, or health statistics, and one of the key things that we can do with a protocol analyzer is performance analysis. And we're looking for certain things like retries versus cyclic redundancy check, or CRC errors. So frame error rates in a protocol analyzer, we usually use retries instead of CRC errors. And the reason for that is sometimes a retry will occur and there is no CRC error because there is no frame that was received at all. The frame can be totally discarded and not really received. So if we're only looking at CRCs, we may not get the full picture. But if we see that there's a retry of 3 times before frame gets through, we know something happened to keep that frame from getting through the other times. So retry rates are important. Utilization is important. So Wi-Fi utilization can be correlated with RF utilization data, but the point is, how busy is this channel? Some of the protocol analyzers do now allow you to correlate with spectrum analysis so that you can integrate the two and see them together. Utilization by PHY rate. So how many devices do we have out there that are using a particular PHY? This can help you identify, you've got some low data rate clients that are connecting, maybe because they're connecting from too far out away from the AP, meaning their signal strength is just too weak, but if they were closer, they could connect at higher data rates. Or it could be that they simply only support those lower data rates. And so that can be something that impacts the overall performance on your network. And then utilization by frame type. So this can help you identify management or control overhead. It can help you identify the kinds of frames, how much of the available time is being consumed by those frames, and therefore may help you make some adjustments, some changes to your configuration and your infrastructure to get a little better performance out of the wireless network. So these are things that you can look at with a protocol analyzer in relation to performance. And the good news is that the major actual protocol analyzers that are designed for Wi-Fi, they actually give you graphs and charts to deal with this information. The question that is often asked and is asked now is, what retry rate is the average in a well-designed Wi-Fi network? Well, there are a couple of answers to that. One is, what kind of Wi-Fi network am I designing? If it's a data-only network and I'm not doing voice over Wi-Fi, things like that, I might be able to get by with a little higher retry rate. But certainly we want to keep it under 10%, and in many cases, we want to keep it under 2 to 3% in order to have an effective network. And some will even argue in some scenarios for 1%, but our wireless networks are getting so congested with so many APs and almost unavoidable co-channel interference, particularly in 2.4 gigahertz, that some level of retry is going to be there for pretty much every wireless LAN, unless you're fortunate enough to be out in the middle of the country region where there's no one around and you're the only Wi-Fi network that's there and there's only 1 AP. Then you might be able to get by with lower retry rates or almost no retries, in that case sub 1%. But I would say definitely when it's above 10%, watch out for it. Usually if it's below 5%, you got a really solid network in that case. Okay, so here's our last topic to talk about, and then we'll open up for general questions. And this is wired matters. So quite often when we're dealing with Wi-Fi analysis, people get so hung up on the wireless that they forget it's not all about the wireless. In fact, a lot of the problems that we have on our wireless networks are not wireless problems. They're just network problems. So that is to say that a wireless network is going to have all the traditional potential problems that wired networks have and the problems that a wireless network introduces. So the odds are when you have a network problem and you've got a wireless LAN and the wireless LAN has been working fine, but now there's something wrong, odds are that it could very well be a wired problem and not a wireless problem. So there are common scenarios where you might look at the wired side for wireless, like wire-dependent protocols, DHCP, DNS. We're going to go to the AP, sure, but getting our DHCP lease, resolving a DNS FQDN or what have you, this is going to ultimately go on the wire in nearly every case because the DNS and DHCP servers are connected with Ethernet. Inter-device communications, like the wireless network management systems, wireless LAN controllers, AP to AP communications on the back end, these things. QoS needs to be end-to-end, right? So you might have to analyze through your switches, your routers, and so forth from a wireless client all the way through to a controller, making sure that you've got QoS all the way through. 802.1x EAP to analyze secure authentication, firewall configuration to make sure the right ports are being allowed through. And so the question then becomes, where do you locate the analyzer in the wired network? Well, if you want to capture your 802.1x EAP exchange on the wired side as well as the wireless, you'll need a wireless protocol analyzer, and then you'll need a wired analyzer that can capture basically everything going out the Ethernet side of the AP. And you can capture it. So the point is you need to understand the wired side protocol to know where to place the sniffer on the wired side. And how do you capture then wired stuff? Well, you're in a switching environment, right? And so normally things only go to the switch port they're destined to. Well, what you can do is you can put in a hub between the switch and the AP, and then you can plug your protocol capture device into the hub as well as the AP being plugged into the hub. If the protocol capture device is only doing capture, the hub shouldn't cause great slowdown, even if you're doing some type of performance analysis or something, assuming the hub is at least equal to the line speed of the switch. Then you can also install software on the troubled machine itself, so you're just capturing what goes in and out of the machine. You can do port mirroring or spanning in some switches, so you can say everything that's supposed to go out switch port 10 should also go out switch port 11, for example. Of course, there are taps in some scenarios that might be used as well. So you can mirror the port, and this can give you information. Now, a question was asked, if I'm doing mirroring on the port that goes to the controller, since all of the frames are going up to the controller, would that give me the ability to capture the wireless LAN info? Well, you can capture the wireless LAN packets that go to the controller. Nowadays, it's very common to actually have only management information going back to the controller and using distributed forwarding so that other packets don't go to the controller. But if all you want is management, then many controllers will just have built in the ability to capture those frames and store them in a file so that you can analyze them. So certainly you could do that because the wireless LAN frames, management frames particularly, are going in a tunnel back to the controller. And so you could potentially capture it through the controller itself. If you capture it by mirroring the port that goes to the controller, then you have to understand it is in a tunnel. So if that tunnel is using encryption between the AP and the controller, you're going to have to be able to decrypt that. So there's going to be that issue there. And that's why it's better to go into the controller to let it do the capture if it supports that capability. Okay, so that's our brief overview today of protocol analysis. So what I'd like to do is leave just a couple of moments here for Q&A. For those that were not able to get here for all of the presentation today, or for those of you that are watching on YouTube and won't be seeing the Q&A because I'll be posting this without any further Q&A, do know this will be posted on YouTube. And so you can go to YouTube and the CWNP TV channel, that's CWNP TV, is the channel that you can go to on YouTube to see all of our archived webinars. So if you came in late, make sure you take advantage of that. And I'll leave just a couple of minutes here now. If you have any questions, I'll sit here and wait for those to come in. And if not, thank you very much for attending. And I hope to see you again on a future webinar. So if you have questions, go ahead and ask away.